4.2, solving quadratics by graphing. All right, and just like when we started with systems of equations, we looked at graphs of those systems first. The main point of chapter 4 is not to graph parabolas, although we just obviously did that. We need to know some of the characteristics of parabolas, but mostly what we're doing in chapter 4 is solving the quadratics and finding out what the solutions are for the quadratics. Okay, and this is next thing. Either take a picture of it or screenshot it from your book on page 552. Depending on what type of graph you get will determine how many real solutions there are. Okay, chapter 4, eventually we will talk about imaginary numbers, but for now we're just worried about real solutions. And if you notice in each of these three examples, you should see something in common. Okay, for example, here the parabola touches the x-axis in one place, and there is one real solution. On this particular graph, it crosses the x-axis in two places, which means there are two real solutions. And in this last example, the parabola does not touch the x-axis at all or cross the x-axis at all, which means it has no real solutions. Okay? So what we really want to focus on for our solutions when we look at the graph are the x-intercepts. Okay? That's where you can find the solutions, and that's what we're doing in 4.2 today. Okay? We're looking at the graphs, and we're going to look at the x-intercepts, and that's where the solutions are. Sometimes the solutions have different names, and they will be referred to in different ways. Okay? There are some other terms that will be used interchangeably. Sometimes we call those solutions zeros. Sometimes we call those solutions roots, depending on the context of the problem. All three of these words mean the exact same thing, though. Okay? If you're looking for solutions, you're also finding roots and zeros. If you're looking for roots, you're looking for solutions and zeros. If you're looking for zeros, you're looking for roots and solutions. They all mean the exact same thing. Sometimes, depending on the type of problem, they will use a different term, but they all are the same thing. They are all the x-intercepts. We're going to be looking at other ways in chapter 4 to find those solutions besides the graphs, because they're not always the best way to do this. They can be inexact, but I want you to be able to see the connection between the graph and the solution and the x-intercept. We spent a lot of time in prior to this point in your math life worrying about y-intercepts, and those are important, but the truth is they're not as important as x-intercepts, because the x-intercepts give us more information, and that's what we're really going to get into now. Okay? Questions so far? Let's solve. And we're going to solve this by graphing. And this is what the problems will look like. Okay? We have a quadratic because I have an x squared, so I know it's a quadratic. Before we can solve by graphing, we have to make one side of the equation equal 0 first. And most of the time, you want to leave the x squared term alone. Okay? And move everything to the x squared side. So what would that mean for this problem? Yeah, Tanner.
X squared minus 8x equals 12, or 12 plus 12 equals 0.
Plus 12. So I'm going to just move this minus 12 to the other side, add 12 to both sides. I'm going to get x squared minus 8x plus 12 equals 0. Now we're going to enter that in our calculator. Okay, and that's the point of this lesson today. You're going to enter that into your calculator, except we're going to make one slight change. Okay? And I'm going to show you where to enter that in. We're going to change this 0 to y. And that's the graph that we're going to be entering in. And I'm going to show you how to do that on your calculator. Okay? So, in order to enter this into the calculator, you have to press the y equals button. The y equals button is the top left button on your calculator, right underneath the screen. Okay? There's a couple things that you have to pay attention to. One, where it says plot 1, 2, 3 at the top, make sure none of those are highlighted or darkened in. Okay? Make sure they're just plain. Okay? If they are highlighted or darkened in, arrow up to it, hit enter, and it'll toggle it off. Okay? The other thing I want you to do is go through your y equals equations and just kind of scroll down and make sure there's nothing already in there. Okay? If there's anything already in there, delete it, because it could potentially screw up your graphs. If it and you can't see all the y's. I think it goes down to 10. So scroll all the way down and just make sure you got nothing in there. Okay? If you're done and you've successfully cleared everything out, what you're going to do is enter this equation in. And in order to enter x, the button right next to the alpha button, the green button, it says x t theta n. That's how you get x. It's right next to the green button. So go ahead and enter this in your calculator. And you can hit the x squared button to get the power of 2. Okay. Again, whenever you're entering an x, you're hitting the button next to the green alpha button, x t theta n. That one will give you your x. Okay. And this is what your score should look like after you enter it in. Okay. So again, notice up here, my plots are all off. If any of these are darkened in, you want to go up and turn them off. Okay. And this is what you should have. The other thing I want you to be careful of is this is minus, not negative. On your calculator, you have a negative button and you have a minus button. The negative button is the little white button in parentheses, okay, next to the decimal point. You don't want to put that there. You want to use the subtraction sign, which is right above the plus button, okay? Anybody having trouble getting that entered in? Okay, the next thing you're going to do is just hit the graph button, top right, and you should get your graph. You should get a parabola. Okay, the graph button, top right. Go ahead and press it. Okay, and then take a look around, make sure you have it entered. Make sure you guys have the same thing. Okay, you should all have the same graph. Now, if you've played in your graphing calculator before, your windows might be a little different from one another. Okay, so I want you to go in and change the window. And so what I want you to do is press the zoom button. This is what your graph looks like, by the way. Okay, press the zoom button, which is top, middle. And on that zoom button, you have a bunch of options. Don't go into window. Get out of window. Go to zoom. And then number 6 is Z standard. Hit that. Just hit 6 or arrow down. That will always take you back to the standard 10 by 10 window. Okay? So that means 10 up, 10 down, 10 right, 10 left. Zoom 6. So eventually you're going to zoom in on some of your graphs, which you can also do on the zoom menu, the zoom button. Okay? Here's the one thing I want you to know about zooming in and zooming out. Okay? When you go to the zoom menu and you go to zoom in, okay, it will take you back to the graph, but will not zoom in until you hit enter again. And it gives you the option to move the cursor to where you want to zoom into. Okay? So like, for example, on this problem, it seems pretty obvious to me, I don't know about you, what the x-intercepts are. Like, what are the x-intercepts for this graph? What's this number going to be right in here? 2. What's this one going to be? So they're exact values. If you weren't convinced of that, you could zoom in and see where it actually goes. Okay? In fact, next to the zoom button is trace. Go ahead and hit trace. And you'll get a blinking cursor on your graph. It's literally on the graph. Hit the right and left arrow buttons and watch it move on the graph and give you the coordinates of the points. Okay, so if you arrow over toward the x-intercepts, you'll be pretty confident that the x-intercept is 2 and 6. Right and left on that, and it'll just move up and down the parabola. Okay? In this case, since there are exact values for x-intercepts, what you're going to do is just write those down as your solutions. X equals 2 and 6. Those are my two solutions. I don't write them as points because they're actually solutions to the equation. Even though those x-intercepts are 2, 0, 6, 0, we just write x equals 2 and 6, and those are going to be my solutions. Okay? So for the first half of your homework today, they're going to provide you with a graph and say, what are the solutions, and you pick them off. Okay? for the second half of your assignment, you're going to have to generate graphs like this. And what I want you to do is take a picture of your screen from your calculator and insert it into your homework. I don't want you to hand draw your graphs, okay, to find the solutions. All right. Any questions? All right, let's move on to another type of that you're going to see. So if you want to take a picture of this or if you want to write it down, feel free. But sometimes, and this is why using graphing as a way to find solutions isn't always ideal. Sometimes the points, the x-intercepts will not have an exact value. And when this happens, using a graph, you're going to state what integers the x-intercept is in between. So after you get this problem into your homework, go ahead and enter this equation in. So it's already, 0 is already by itself, 0 on one side of the equation. One side of the equation is already 0, there we go. Enter that x squared minus 6x plus 4 in, and if you want to replace the first graph, go for it. For those of you who have the LCD screen, the newer ones, you can enter it into Y2, and it will actually make your graph a different color, so you can tell which one is which. It's up to you how you want to do that. I see a lot of you have the older one like I have, where it's just the black and white screen. You're probably better off replacing it rather than entering it in a different Y2. So go back to the Y equals screen, enter it in, and then we'll go from there and show you what to do next. So here's what you should have had. Here's what your graph should kind of look like. Now if you notice here, and you can zoom in on it if you want, this one is in between two integers. There's not an exact value for this x-intercept. And this one you can see is slightly to the right of 1, 2, 3, 4, 5. Right? Again, if you wanted to zoom in, you could do that. So if you hit the zoom button, let's do that. Hit the zoom button, which is top middle, and then zoom in is the second one down, and hit enter. Now it's not going to do anything yet, but move your use your arrows to move to an area where you want to zoom in on, and then hit enter, and it will zoom in for you. Okay, and then if you want to go to trace, you'll see that it won't go in. That it's definitely not in between. For that matter, if you want to just move the cursor, you can kind of get close to where that point is, and you will see the coordinates of that at the bottom of your screen. Okay, so in this case, what it wants you to do is state the consecutive integers in between where the roots are located. So what integers is this solution between? 0 and 1. Okay, so that's all you need to say. Okay, one solution is between 0 and 1, instead of trying to guess what that value is. Okay, what about the other solution? What is it in between?
6 and 7.
Well, if this is 1, 2, 3, 4, what's this one? 5 and 6. So this one's between 5 and 6. Okay, so that's all you're going to do today. You're going to for the first half of the problems, the book has provided the graph for you, and you're going to state what the solutions are, if there are real solutions. In some of them there are going to be no real solutions. Okay? Or you're going to have a situation like this where you're going to state the consecutive integers that is in between. Okay? There's one other thing I want to show you, and I still have it for actually let's see if I can do this. So this is for the first equation. Okay, this is a table for the first equation. If you notice here, once you have something entered in the y equals screen, you can generate a table from your calculator. Okay, so this, if you hit second in graph, this is the table for the first equation that we did, because I didn't change it. X squared minus 8x plus 12. These are the actual points, the integer points on the graph, which I realize at this point you've been generating by hand, but You can find these just by using the table function here. For any equation that's in the y equals screen, it will generate a table of values for you. And you can just move up and down, and it'll give you different x values and the corresponding y values that go with it. So this calculator has lots of functionality, and for those of you who haven't played around with it at all yet, I suggest you do, because there's a lot of things there that are pretty cool. And it does fractions. Those of you guys who haven't figured out that these do fractions, if you hit the alpha button and then y equals, you'll get the fraction. Because I know some of you like those baby calculators because they have fractions on them. These also have fractions on them. Alpha y equals, we'll get that n over d. You enter that in, and now all of a sudden you can do fractions, okay? And it'll generate a fraction on your screen. So you just hit enter once you get to that, and it'll turn into a fraction, okay? Questions?